Okay, class, so welcome to today's lesson. Today we're going to look at changing equations. So we've seen so far that when we have the equation y equals, say, 2x plus 3, then we make our table of values x, y, -2, -1, 0, 1, and 2. Some easy numbers, and that's because our rate of change, the number in front of x, is an integer. So when you have an integer, you simply always go to those numbers. Those are our go-to numbers. But when you have y equals, say, 3 over 2x minus 7, well, now you have a fraction. You don't have an integer. And so we don't want to have to graph fractions. We don't want fractional answers for table values because that makes it hard to graph. We won't be able to do it accurately. We'll just be guessing a lot of times about the exact location. Whereas over here, we will know the exact location because those will be integers and they'll be on the corner of a grid. So what we're going to do then is we're going to use multiples of the denominator. And we saw that yesterday. So we start with the negatives, -4, -2. 0 is always a very interesting number. Always plot 0 when you graph because that's when it crosses the middle axis and you want to see what happens then. Then we have +2 and +4. That will then allow us to get integers. Okay? And so we'll have integers for our x, and we'll also have integers for our y value. And so then we can now plot accurately. But today, we're going to see that we're going to have equations like this. 3x minus 4y equals 7. And so we don't know, is this going to be a fraction or an integer? We don't know. And so what we want to do is we want to then graph integer. We want to be able to change that. Okay, when we have an equation, we want to change that so that we see it as a y equals. And then when we have y equals, we can see what our rate of change is. Okay, so we can then see it once we change it. And the rest part doesn't matter, a constant value. So you've already done all these skills. You already have them. You've been doing since grade 7. We're going to be using our algebra rules. It gets a little bit different because you're just going to be moving things and things aren't going to be disappearing and canceling out. So remember, our algebra rules is do the opposite operation, and then we will have to keep it equal. So we have to do it to both sides. Okay? So if we subtract from one side, we have to subtract from the other. And that's what we mean by keeping it equal. So our opposites are, if you see addition, you do subtraction. If you see subtraction, you do addition. If you see multiply, you do divide. There is, of course, if you see divide, then you should do multiply. But we actually have some more techniques because you're going to have fractions when you see that. And we'll be talking about fractions next year in grade 10. Okay, don't worry about them now. So here we have 2x plus y equals 3. We want to move this 2x. So this is a plus 2x. And you can tell that by looking in front of the 2x, not behind it. So in order to move the plus 2x, we have to subtract 2x. And we have to do that to the other side. Now when you first started, I showed work like this, and your other teachers might have showed work like this. What happens on the left side? They cancel out. So you're left with y equals. Now we want to put -2x here, and then this is a plus 3. And so we have the positive sign turn into our plus sign. That part's a little bit weird. Okay, positives are pluses, negatives are minuses. We talked about that. And the reason why is because we always want our graph into y equals mx plus b format. So this here would be your rate of change. And this here would be your constant. Okay, and we'll be talking more about that next year. A little bit this year, but not too much. Good. So then we have question number 2. Question number 2 is a bit tricky. It's 3x minus y. But again, you look in front of the 3x and you see that it's a plus 3x. So we have to minus 3x. Don't look at the subtraction sign behind it because it has nothing to do with the 3x. That subtraction sign belongs with the y. And that's what we're left with. We're left with a negative y. The 3x's cancel. And so we're left with negative y equals negative 3x minus 4. So now we've done this before. How do we get a positive y? Well, the truth is that in order to get a positive y, we have to do the opposite. Timesing by -1, we divide by -1. So the entire left side is divided by -1, and then the entire right side is divided by -1. And so we get y equals, and on the right we get sign changes. So both parts must get divided, so both terms, or parts, must get their signs changed from a negative to a positive. Okay, so we're going to go look into more negative division over here, or more division rather, with the next one. So this next one now, we have 4x plus 3y, so you look in front of the 4x, and it becomes a minus 4x, both sides. And so you're left with 3y equals negative 4x plus 12. And now what we have to do is we have to divide the right side by 3 because we're dividing the left side by 3. And the entire sides must be divided, okay, the entire sides. So y equals, well, we can write this as two separate divisions. So just like over here, we divided each one by -1, really what that was a negative 3x being divided by -1 and a negative 4 being divided by -1. So using that idea, we bring that over here. We have negative 4 divided by 3x plus 12 divided by 3. Now, if you want to write that as negative 4x divided by 3, that's fine. That's okay for now. But now the next step is to actually do the divisions. But since you can't divide, you're just going to write it as a fraction, which is a division. And now with the x, you could write it up top, but you don't need to. You can write it right in the middle because the x is going to be multiplied by the answer to this division. Okay, so that will be the exact same math. It doesn't matter what order you do that in. And 12 divided by 3 is 4. Okay. Now, next year in grade 10, you're going to look at this and you're going to be able to graph just by looking at that. You won't have to do a table of values. But for us, this year, we would then be able to do a table of values. We would know then, when we do our table of values, our x's would be -6, -3, 0, 3, and 6. And then we could get easy integers. Okay? Then this would then be easy. Okay? Easy integers. And that's kind of what we're looking at and why we're kind of learning how to move equations around. In grade 11, next year in grade 10, you're going to do this all over the place in many different ways. Okay, so let's move this one. You go, give it a shot, then double check. So we have to move the 5x by subtracting. We're left with -10. And always write it with the x term first and the constant term second. So remember, this is a plus 4. Really important to see that. Now we're going to divide by -10. So divide the left side by -10, divide the entire right side by -10. Now some people like to go and just go -5x plus 4, and they just go, oh, -10, -10. I got no problem with that. And they kind of miss the step up above. I'm okay with that. Try not to do it all in one step, because you're going to lose some of the details. So then you have to simplify your fractions, and then that would divide by 2. There we go. Now that one's a pain in the butt. That one's going to be hard to graph, absolutely. But today we're just working on changing our equations, so don't worry about it. And the next one here, we have move the x. So you try it. Go for it. So I'm going to start by moving the 8 actually. It doesn't matter what I start moving first. It's still going to be the exact same. Okay. Then I move the x. And you can see I'm showing a little bit less work here. Then I divide by -1 and my signs must change. Okay. So question number 5, this, if you're an expert, this is how you're going to be showing your work at the end of the day. But show the little steps, because otherwise you'll lose the details. It's easy to make a small little detail error. All right. So then your homework is going to be just like this. Okay. So for your homework now, you have this cryptic quiz. Okay. And so you're going to check on here. You can probably do your work on this sheet or do it on a separate sheet of paper. But here I'm going to go minus x, and so I'm going to get y equals negative x plus 5. And so then I look at my answer, y equals negative x plus 5 right here. And so wherever there's a number 1, I put the letter P. And so here's a number 1, I put the letter P. Okay, so you got to do your cryptic quiz, and then you'll get 2 phrases. They're not funny, they're just phrases. All right, any questions, let me know. And the next part we're going to look at is interpreting graphs even easier. Okay, so graphing. Real-world graphs are used all the time to make predictions. So you can make predictions for your business or for cities or for management or a whole bunch of different things. So here you go. How do you think city planners can predict the volume of water needed for the residents in the future? So we're going to be interpreting graphs. So use interpolation and extrapolation to do this. So it's quite simple. Here's your graph. What they've done is they've graphed the monthly water usage for people at different levels during the population increase. So they know that in this city, this is what people are using. So what if we have say we have people move or whatever, okay? We can get information from this graph. So here we have the plotted values right here, 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 and here. But then we can show the relationship by making that straight line. And using that relationship, we can find values that are in between those points, or even below those points, or even above those points if our graph extended. And that's why graphing is so powerful. Okay, so let's, for example, say, hey, you know what? We're going to have a shortage of water this summer. Let's say that our water, instead of our regular water, we're only going to have 1,500 million liters. So what population would that cover? So you take your ruler, okay, it's a new device, it's just invented, and you draw a line starting in this axis, because this was our starting number, and we draw the line over to our graph, right to that point. And so we want to figure out what is that value. So to figure out that value, then we have to go down. And so we then go down. So from this point, oops, let me get that line again. From this point, we go straight down. And I'm a little off, you can see that. Okay, making sure your ruler is straight right at the point, right where your two lines touch. And then you can see that it's water usage supports a population of 200,000 people. Okay, and that's how you interpret your graph. You basically find one number and go straight across to the graph line and then go down to figure out the other number and the relationship between those two ideas. It also works in the other direction. So say we had a population of, I'm not sure, say we only had a population of like 75,000, okay? Actually, let's go 50,000. So here is 100,000 people. So 50,000 people would be in between those 2 points. It would be right here, okay? So that would then be 50,000 by reading our graph. So what do I have to do? I draw a ruler. With my ruler, I go straight up to where it touches the line, and then I go straight over where it touches the other line. So what is that number? Well, this number is about 250. So I'd say this number there, let's see, we're going up by quite a bit, another 250. So I'd say maybe we go up by another 200, something like that. And so another 200 then would be 450. So we can say it's about 450. Now, that's a little bit high. I would also take an answer of, say, 425, take another answer of, say, 440, 430, something like that. Okay, so this squiggly line means approximate. Okay. Now, most of the questions I'm going to give you are going to be a little bit more than just approximate. It'll be a little bit easier than this. That was a pretty tough question. But we can do this for other graphs as well. So for this graph here, this is a graph of a car journey. So we can say, well, after 3.5 hours, how many kilometers did they travel? So 3.5 hours, we would look on the hour grid. It would be right here. And you would go up, and you can, with a straight line, so up vertically to your graphed line to see the relation.